Hello everyone, welcome to the place where we learn a Verilog HDL, beginner to the advanced. In this first lecture, we describe what is Verilog, why we need the Verilog, what is the comparison between the Verilog and other programming language, what is the method in which we write the Verilog code, and the such basic concept. So let's start. Our first question, which use what is a Verilog? Verilog is basically, we can say that it is the hardware descriptive language. Hardware descriptive language which use in a model, simulation, synthesis, or we can, in a simple word, we can say that it is the hardware which is used or represent as a digital. Okay. So why Verilog we require? In ancient time, they used a small, large, a big room paper, and usually people design manually the transistor circuits, which is very complex and time consumption. But in Verilog, we have to write among 69 codes, and we get a ready-made circuit of transistor line. So the Verilog is basically used in FPGA or ASIC design. We required another lecture for ASIC flow, in which the IC made from a first start point to the end point all we covered. For now, so what is the main difference between the Verilog and other programming language? So other programming we can take an example of C language. Okay, the C programming where we estimate to the 10 line written in a code. It will execute first line, second line, third line, fourth line, fifth line, 6, 7, 8, 9, 10. Okay, then it debugging. But in Verilog, it executes in sequentially. The 1, 2, 3 at the same time. It consumes time and gives the accurate design of the hardware. To design the hardware, there are the 4 methods. First, gate primitive. What is the meaning of gate primitive? It is the basically, we can say, the NAND gate, OR gate. Okay, we have an example that we have to design the one circuit like this. Okay. So by using only gate, we use one AND gate, one OR gate. We design this circuit. So by using gate, we can get a gate primitive. Or second is behavior. We can say that the AND behavior is A, B, and there is A point B plus C. It is the expression of a Y. Okay. So by writing this expression, or we can say it is the behavior of this circuit, that is called the behavior modeling. Third is the structure, in which we have to design one full adder. Okay. So we can design the one half adder. We can design the full adder using the half adder. First we design the one half adder, which copy, paste, and which build a full adder. Okay, to reduce the complexity, we use the structural model. And Dataflow flow is a one type of a modeling. So to initialize, to write the code, we need the basics keyword, or we can say some blocks to initialize the design. This is the first module. In initial programming, we have to write the module. It is the basic building blocks which used to initialize the design block, in which we describe the hardware components. Okay. Second is a register. The register is we know all that what is the register, which used to store the values. Same use in a Verilog programming. Another is a wire. To connect, we can say this is the example. Okay, this wire I have to connect in the AND gate. It is just one type of wire which is I have used physically in a breadboard. To describe the hardware, we also used in a Verilog the wire. Okay, so let's start our basic code, the AND gate. We initialize by module, and is a name you can set the. Okay, we initialize the module, and we can set the any name. Okay, in this first we have to design like this AND gate. Okay, a y input A and B. Okay, input are 2. I have initialized the input A comma B comma. Okay, output 5. Okay, done. This is initialization. This block which used to initialize the input and outputs. Okay, then we use the gate primitive. We have used the gate primitive. By this modeling, we design the AND gate. Simply write and in this you must require to write a first output. Y is our output. I have written is first, and second A and B are the two inputs. Okay, comma, semicolon, and the module has been started. We have to end module, so simply write the end module. This is the simple code for a AND gate. In a further lectures, we design the all gate with the gate primitives. We will design the combinational, all sequential, FSM, timing machine. We understand all the briefly. For now, it will be okay. The further lecture will be as soon as possible. Thank you, and subscribe and like for more.